All right, we're talking about analyzing graphs of functions. This is the pre-calculus section. 1.2, we're going to go through the whole shebang. This is everything we went through today. I'll talk about the homework. I'll tell you what the homework is for those honors guys that I already assigned this homework to. Everybody else already knows what their homework is. But I want to get you started on this, and this is what we looked at in class. If you weren't in class, I'm going to go back over it. This is the second part, and here's the first part. All this is analyzing the parabolas that you saw, or the graphs that you saw, and it's a very simple idea. Every graph of a parabola that we saw had a couple of points where the parabola cut through the x-axis. Those x-intercepts are zeros. It had a y-intercept, and it had some sort of maximum or minimum value for y, and then we could do a few things. Now, the first thing we talked about was the domain and the range of a function. Now, if your parabola looks like this, or it's pointed upward, it has a domain that's infinite, pardon me. So that means it goes all the way to the left infinitely, and it goes all the way to the right infinitely, and that's the way it is, all right? So you could notate the domain of this function, and I guess I'll put it down here. The domain, don't tell the other guys I wrote this, but the domain is negative infinity through, pardon me, positive infinity, and that's it. And if we wanted to write it in set builder notation like we did before, and that's for you honors guys, I always want you writing in set builder notation, you could say just simply x is an element of real numbers, right? And there it is, x is a real. And that's it. X, the domain of this function is that x is always going to be some sort of real number. Now let's talk about the range. Well, the range is a little bit different. That's the y values. And it tops out here. And they gave you a point, and this point happens to be 5.0625. Okay, that's wonderful. But everything below it, it goes downward infinitely. So we can say that its range tops out and includes 5.0625, but it goes down infinitely. And then we put our parentheses around it. And if we wanted to, we could say in set builder notation, if we do this right, there we go, y, a set of y's such that y is less than or equal to 5.0625, where all y's are elements of real numbers. And then we can close our brace, and there we go. Right? So we've been able to do this, and this is not a big deal. I hope you all understand what x and y intercepts are, right? It's those points where the graph touches the x-axis, that's the x-intercept, and the y-intercept is where it crosses the y-axis. Now, for this function that we were given, function of x is negative x squared minus 1.5x plus 4.5. That's a pretty easy function to figure out what the y-intercept is, right? Because if we set this x to 0 and this x to 0, what's left over is our y-intercept. And if you remember in slope-intercept form, y equals mx plus b, when you zeroed these guys out that had x values, what you had left over was that y-intercept. And so it's pretty simple. If I want to know what the y-intercept is for this function, we could just simply say this constant here is the y-intercept. And I'm trying not to use up all the space here, but I'm trying not to get on top of myself here. But you can see that that's the y-intercept. So if there's any constant, if your function has any constant, then you definitely have that constant as your y-intercept. And you'll look at the graph, and you'll see, oh yeah, it does cross at 4.5. You know, if this is a little over 5, then this definitely is 4.5. The only other thing we need to find out are the zeros of the function. Well, here's how we do it. If to find the y-intercept you set your x's to 0, well, to find your x's, you're going to have to set y to 0. And this f of x is the same thing as y. So you're going to set this function to 0. And you're going to end up factoring. Negative x squared minus 1.5x plus 4.5. All right, well, I can't do anything with this. I don't like this negative. I'm going to factor out a negative 1. And I'm going to rewrite it as x squared plus 1.5x minus 4.5. And I'm going to say to myself, hey, I know how to factor this. X times x gives me x squared. One's going to have to be positive, one's going to have to be negative because of this negative sign. And you've done this factoring before. I want two factors of 4.5 whose difference is 1.5. And the truth of the matter is it's, must have done that wrong. I must have written this wrong. Yep, I did write it wrong. I think, if I'm not mistaken, minus plus, positive 3, and negative, there we go, negative 1.5, there we go. All right, so I found it. Oh, can't believe it took me that long. Sorry about that. Anyway, here we go. Positive 3, negative 1.5, right? Wrong. This equals 0, so we make x plus 3 equal to 0. We make x minus 1.5 equal to 0. And we know that x equals negative 3. Please tell me you know how to solve these that way, and that x equals 1.5. If you don't know how to solve them, we can go back and I can do another video on solving equations. Actually, you can pull my videos from Algebra 2 class because that's exactly what I'm doing right now if you don't know how to solve equations. All right, so this says that one of these crosses at negative 3. It looks just about right, and just about half of that is where this other part of the parabola crosses the x-axis. It looks like we did a great job. All right, so that's it. You analyze the graph, you analyze its domain, all the x's. If it's a parabola, it goes equally in both directions forever and ever, right? The range, you find out where the bottom of it is and then everything else above it. If it's opened up to the sky, like this type of parabola. This type of parabola, you got a top right here, and it opens downward and goes downward forever, right? That's the range. Find your intercepts. Everything looks good here. So let's start talking about the other piece of this puzzle. Let's start talking about symmetry. This is a very symmetrical parabola. But the problem is it's shifted, right? So this parabola doesn't help us. It doesn't have perfect symmetry across an axis. So this parabola, for example, is neither even nor odd. So let's start talking about even and odd. An even function is a function that is symmetrical if you flip it around across the y-axis. All right? This function here is an odd function, and it's symmetrical across the origin. So catty-corner symmetry. Oh, look at that, catty-corner symmetry, and that gives us an odd function. They look different, right? Here's an even function. Both of these exponents are even. We don't care about the constant with an even function. It doesn't bother us. It doesn't shift our function at all. And then lastly, here we have an odd function where both of these exponents are odd, and we're going to end up with something that looks like this and will be symmetrical across the origin. So even, symmetrical across the y-axis, odd, symmetrical catty corner across that origin. That's really all there is to it, and you can really analyze it. If it has both odd and even exponents, most likely it's going to be neither. All right, and it won't have any cool symmetry. It may look like this, but this would be shifted over. It'll actually be shifted up and shifted over. Oh, I lied, down and over, because of the way it's written. All right, you're going to use a graphing calculator to finish your problems tonight. I'm going to post the practice page for the honors pre-calc class. I gave you this in class. If not, I have a copy of it. I just pulled it up on my computer. I'm going to post it on Google Classroom. You're going to basically use a graphing calculator to take a look at this stuff, or else you're just going to analyze it. This is usually very, very easy. You can basically look at the x and y intercepts just by looking at the graph. You can figure domain and range by looking to see if there's a dot. On this page itself, there's a graph that stops right here. It has a dot, and they give you the point in space so you can figure out what the point is. And that'll be the extremes of your range and your domain over there. But down here, it's infinite in both directions. Right? It's infinite in the x direction, the negative x direction. It's infinite in the negative y direction. But there would be a point here, so you would be able to figure out your domain and range. Other than that, you should be good to go. Again, you have any questions, send me messages on Google Classroom, and I'll help you out. I hope this is okay for you. This is obviously a long video, but remember, go back over the video if there are things that you don't quite get. See if you get it the second time. If not, send me a message.